Okay, here we are at the last section in Chapter 4. We will be modeling quadratics today, that is modeling with quadratic equations. Modeling is a mathematical term for producing a mathematical representation of a situation or phenomena. Phenomena just means something that happens. So really what we're doing is writing an equation for a thing. Usually in Algebra 2 it's a thing that somebody gave us, your book or me. So we're just going to write equations for stuff. We're going to use quadratics now. Our three basic forms for quadratic functions are standard form, vertex form, and intercept form, and you're going to want to pick the form that represents the information you've been given. So my general advice for how to proceed from modeling is to think first about what information you've been given. Any of the forms is going to require three pieces of information. But you want to fill in information directly if you can, because any information that's left over is more annoying to deal with. So if you're given a vertex, use vertex form. And if you're given intercepts, use intercept form. At the end, though, you are going to have to finish by sticking in whatever additional information you have for x and y and solving an equation. If you're unlucky, if you're doing one of the more complicated problems, then you're going to end up with more than one equation to solve. We'll get to that at the end. So vertex form is probably the easiest to use this way. You can use it when one of the pieces of information you're given is the vertex. Now I know I said you need three pieces of information, but keep in mind that when you know where the vertex is, you also know where the axis of symmetry is, which technically counts as two pieces of information. So vertex and an additional point will do, especially because also if you had your additional point, you could find the reflection of that point. This works for us anyway. So filling in the information we know directly first means the vertex. So remember, h and k represent the vertex, so the x and y for the vertex go in for h and k respectively. Y and x are supposed to be in your equation, which means the only number we're missing is a, which means we have one number to find. We only need one equation. So we can stick in this 1 and the 4 for x and y in order to find a. So y becomes 4 and x becomes 1. Notice 1 minus 2 is negative 1. Negative 1 squared is 1. So 4 is a plus 3, which makes a also 1. Since we know a is 1, now we can rewrite our equation. Y equals x minus 2 squared plus 3. That's our final equation. Vertex form, pretty straightforward. You have to stick in the additional point to find a, but that's all there is to it. So let's do one more. If my vertex is negative 4, 2, and my additional point is 0, negative 6, first I fill in the vertex. Note it's x minus negative 4 in this case, which x minus negative 4 is x plus 4. But I still need to find a, so I stick in 0, negative 6. 0 plus 4 is 4 squared is 16, so this is 16a plus 2. I subtract the 2, divide by 16. A is negative 1/2. So here's my equation. Negative 1/2 times x plus 4 squared plus 2. Intercept form works out in a very similar way, except for when you have intercepts instead of a vertex. Because we don't know where the vertex is, we do need all three pieces of information, two intercepts and an additional point. This is an example here. 2, 0 is an intercept, 7, 0 is an intercept, 3, 6 is my additional point. I'm going to fill in the information I have, which is the intercepts. Those go in for p and q, 2 and 7. So x minus 2, x minus 7. To find a, I'm going to stick in the point 3, 6. So 6 is y, and x's become 3. 3 minus 2 is 1. 3 minus 7 is negative 4. So I divide the negative 4 and get negative 3/2. Y is negative 3/2 times x minus 2 times x minus 7. You could expand this out, but you really don't need to. Doing intercept form again, this one, watch out because this right here is a y-intercept. It's neither p nor q. This is our additional point. Negative 2, 0 is, negative 2 is our first intercept and 4 is our second. And again, x minus negative 2 is going to be x plus 2, although then x minus 4. So I stick in 0 for x and 24 for y to produce my equation to solve. Positive 2 and negative 4 makes negative 8, so a is negative 3, which this is my equation. You can stop here. Now, I said before you could expand this. This one doesn't have fractions, so it's not too bad. If you FOIL these together, you get x squared minus 2x minus 8. You can just distribute the 3. Right, that turns it into standard form, which some people prefer. I think less work is better. For a standard form, this is going to be when you're not given the intercepts or the vertex. And so there's going to be any 3 points where you don't know if one of them is the vertex. One could be, but you're not told for sure. And you note that you don't have enough intercepts to do intercept form. So there's no information to fill in directly. There's 3 letters left, A, B, and C, that we have to find numbers for, which means we have to use all 3 points and produce 3 equations, because we have 3 unknowns. And so this is where things start to get a little hairy. Notice when I use 410, this is x squared, it's 4 squared, and x by itself. If I use 1, 4, 4 is, here's x squared and x by itself again, and negative 2, 16, y is 16, the x's are negative 2's. This is 3 equations with 3 unknowns. This is a system of equations. I recommend you use a matrix to solve these. You could do it by hand, but remember those ones took forever. So let's produce those again, but put them in the order we're more used to seeing in chapter 3. Notice the 10 is y, and 4 squared, right, x squared here. 4 squared is 16. We just have 4. For 1, 4, the x's become 1, so 1 squared is 1, and just a regular 1, c is all by itself always, and y is 4. Negative 2 squared is 4, then we have negative 2 by itself, and then just c by itself, and 16 is y. Putting this into a matrix equation, looks like this. Remember, the coefficient matrix times your variable matrix equals your constant matrix. On the calculator, you're going to type in the coefficient matrix and the constant matrix and do the inverse of the coefficient matrix times the constant matrix. And that's going to give you your answer. Note A is 1 and B is negative 3 and C is 6. So this is 1x squared minus 3x plus 6. Let's do another example with standard form. Here I've got 3 points. Note one of them is a y-intercept, but since I don't have 2 x-intercepts, I got to go with standard form. When I produce my equations, then x is 0 for the first one. Remember the c is by itself, and then negative 8 is y. The second one, x is 1, so 1 squared is 1, 1, and then c is by itself. 2 squared is 4, 2 by itself, and the c is alone, and here are our y's. So you can just put this in as a matrix equation and not worry too much about it. Although because the top one, x is 0, I have to know c is negative 8, which means I could solve the other 2 systems as a two equation system. Note a plus b minus 8 is negative 3, and 4a plus 2b minus 8 is 6. So I get, when I add 8 to both sides, I get 2 equations. Maybe easier than doing a matrix. Multiply the first one by negative 4, and then add. I get 0, negative 6b, and negative 30, which means b is going to be 5. Once I know b is 5, a plus b is 11, so a is 6. Now it's 6, 5, and negative 8. Well, like I said, you could have gone straight to the matrices and put 0, 0, 1 in your matrix. That would have been fine with me as well. Either way, we produced an equation. Going back to remember everything we've done, fill in stuff you can, so pick the form that lets you fill in the most stuff, but you're going to have to substitute for the rest of the points. Vertex form is for when you're given a vertex, you need at least 1 additional point. Intercept form, you need both intercepts and 1 additional point. And then standard form is the last resort. I recommend if you're going to use standard form that you go right to the matrices.